Hello 108 students, Mr. McHugh back here with you on section 7.4. We have been working hard. We're going to tackle page 4 here. This is the last page of our class notes. And we are going to do some graphing here in this last section here. We want to get comfortable with a rational equation. Remember, rational means it's got a rational expression in it, and the simplest one you can have is just called the parent is f of x or y equals 1 divided by x. Okay, there's your variable x, and they call this the inverse function because look at this for a second. If I give you a value of x equals 2, if x is 2, the output y would have to be 1 divided by 2, which is a half, and 2 and 1/2 are reciprocals of each other. Okay, so that's why they call it the inverse function. So I wanted to spend a lot of time explaining this here to you, and then so let's go ahead and get through this basic parent graph here, and then we'll get to finish this up. So first thing you always do is whenever you see the variable is down in the denominator x, think of the restrictions. X cannot what, class? Can never equal 0. Okay, so that one's easy to know, and that means when you regraph this, x equals 0, there will be no values for it. Okay, it takes a little while to see this, so well, not a little while, but you'll get the hang of it. But remember that the restriction is that x cannot be equal to 0. Okay, now what the book likes to do is they do these horizontal tables. On page 389 is where I'm working here with this objective, and I strongly encourage you guys to make expanded XY tables the way I've done them here. The book likes to say here's an X, here's a Y, and they leave out the nitty-gritty detail. Well, I want you to get down there and get down dirty and figure that out. Okay, so here's an idea. Pick values for X. I picked a couple of them, -3, -2, -1. I stuck it down here, and here's 0. We said X cannot equal 0, and we said it was undefined. I put a dash through it. Okay, undefined. Doesn't exist. So we're going to do a graph where we are not going to, when x equals 0, we are not going to cross that. Okay, so keep that in mind. Now, go back up here, follow x is your input. You're going to put it down in the denominator, so it's 1 divided by, what, -3. Output is -1/3. The ordered pair, the input was -3, the output was -1/3. So you see a number and you see the reciprocal? Okay, -2. 1 over -2 is the output, which is -1/2, and that's what we're going to graph here. Now look what happens when you go into the positives. Put a 1 in here. You have 1 divided by 1, which is equal to 1. Order pair 1, 1. I want to make a little note here on this guy. This is called the elbow point. I think that'll become obvious to you once we graph these guys. These graphs look very strange. They're a little different here. They're not a line, they're not a parabola, so we got to get comfortable with them. You put a 2 in for a +2, 1 over 2. There's the reciprocal is 1/2. There's the ordered pairs, and you're getting the idea. 3, 1 divided by 3, 1/3. And we're in this guy, when you put -1 in, he's also an elbow point. Okay, so take those ordered pairs. Let's think about this for a second. X cannot equal 0. So on the x-axis, where's 0 at? Right at the origin. Okay, now it cannot equal this. We're going to give this a phrase. It's called the asymptote line. Be careful how you say that. And while this is the y-axis, it is also where x equals 0. And I'm going to try to highlight this with dashed lines coming through here. Okay, we are not going to have any graph cross this vertical line. Can't happen. Okay, now what I started to do was I took my ordered pairs that I got here, -3, 1/3. I graphed it. -2, 1/2. -1, 1. Now look what happens there. Okay. If I would put a -1/2 in, I didn't show it up there on the graph, but reciprocal of -1/2 is -2. Reciprocal of -1/3 is -3, and those are the ordered pairs. Okay, and so these graphs are really interesting because of these fractions. Look on the y-axis. On the y-axis, y equals 0 is the x-axis, but from the y perspective it's 0, and notice this graph will never cross it. Okay, and that's because when you turn around there and put values in, or a fraction, no matter what number you put down in that denominator, it's always 1 over the number. Therefore, it's going to be a fraction. The bigger the number gets, the smaller and smaller the output is. And so my graph, unfortunately, if you look in the book, it's a little better. It really goes like this. It gets close and close and close, but it never ever crosses. It won't even touch that y equals 0, aka x-axis. Coming down here on the y-axis, aka x equals 0, we know it's never going to cross, because no matter what fraction you put on there, you're never going to achieve 0, because you're never allowed to divide by 0. So study that for a little bit. Okay, I find these graphs fascinating, so that's why I'm trying to take some time here, and I want you to go through and study these things, so when you get to the homework problems, they make sense to you. Now, I picked a couple values for y of, if I pick a half, 1/2, I get 2. That's the ordered pair. Remember, they're reciprocals. You pick 1, you get reciprocal 1 is 1. This was an elbow point, and -1 comma -1 was an elbow point. Now, the reason why I call it an elbow point, look at these guys. This guy is going horizontal. It's starting to bend a little bit, and boom, as soon as it hits the elbow point, whoosh, so takes a nosedive. Look at this. This is going vertical, going vertical. It's bending a little bit, hits that 1 comma 1, and then boom, it goes, looks like it's almost going horizontal. Now again, as I draw these, you are getting approaching the x-axis, okay, y equals 0, but you never cross it. Okay, and that's because of that reciprocal in the fraction. Okay, so that's the idea here. One of the first things you want to do here when you're from homework problems, you're going to pick these from multiple choice, so you just got to get a feel for these. I am going to go ahead and offer a bonus. Page 5, I'd like you guys to take a look at it. I am going to do example 6 in the book on page 390. So look for me to come back and do that. And I want you guys to see how you can try to give you a couple shortcut tips here to help you figure out what the correct graph will be for those. Okay, Mr. McKee, I'm going to sign off here. We're doing a good job here. We basically have finished 7.4. Got one more example to do for you, but I will catch you for that bonus page. Okay, take care. Bye.